go ahead and investigate graphing our inverse cosine function. So here we have the parent function of cosine. And like we noticed yesterday with sine, we also can see that cosine is many to one. So if we look at our cosine function, even if we just consider our x-intercepts, we can see that there are many x values that will produce the same y. So this would be considered a many to one function. We have many x's yielding the same y value. So in order to find the inverse function, we need to restrict the domain of our cosine function. So if we consider where on our function the interval will be 1 to 1, we can kind of look at our max and mins like we did with our sine function and split it into intervals at those points. So we can see that on these intervals from negative pi to 0, from 0 to pi, from pi to 2 pi, 2 pi to 3 pi, and so on all of these intervals, cosine is now 1 to 1. So the interval that we are going to concern ourselves with for the actual inverse function is this first positive interval between 0 and pi. That's the one we will graph for our inverse function. So we can kind of see, before we flip our page over, we can see that currently on this interval, our domain is between 0 and pi, and our range is between -1 and +1. So remember that the domain of our cosine function will become the range of its inverse, and the range of the cosine function will become the domain of the inverse. So when we write our information down at the top of our next page, we know for this inverse, what is now our x was previously our y values. So x is now between -1 and +1, making our domain between negative and +1. And our y values are between 0 and pi, making our range also between 0 and pi. So we're going to go ahead and, just like we did with sine, we're going to evaluate our cosine function, and then we'll switch our x and y coordinates to graph the inverse. At 0, we have 1, 0, and cosine is the x coordinate. So cosine of 0 will be 1. 3 pi over 2 is 60 degrees, where cosine is 1/2. At pi over 2, our x coordinate is 0. And then we know that 2 pi over 3 and pi will be the same values reflected across that x-axis or that y-axis. So they will be negative because cosine is negative in quadrant 2, where x is negative. So now we'll graph our inverse cosine. And so I have our x-axis labeled between -1 and +1. We have these halfway points. And then my y-axis, I have it increasing by pi over 6 so that we can include all of these different values. So if we go ahead and start graphing, we get 0. Well, actually, these are the cosine values. So ordered pairs will be 1, 0, 1/2, pi over 3, 0, pi over 2, -1/2, 2 pi over 3, and -1, pi. Okay, so we can go ahead and graph these values. So 1, 0, 1/2, 1/3, so that will be 2/6. 0, 1/2 pi will be 3/6. 2 pi over 3 will be 4/6, so there'll be 4 boxes. And then pi will be up here at 6/6. So my cosine function looks similar to my sine function. And we'll go ahead and look at that reflection on Desmos. So here we have our cosine function with the restricted domain between 0 and pi. And if we graph that line y equals x, we can see the inverse function is a reflection across that same line y equals x. So we have that same reflective nature. And again, because we are switching the x and y, it's performing that reflection, and it also creates the inverse.